All right, here we go. Multiplication. Bases are the same. Exponents, what do we do with them? Add them together. This is what we did in chapter 7. Let's go ahead and a to the 6th. 3 plus 3. Power to power. What do we do? Ivan? Multiply 3 times 3? 9er. A to the 9th for number 2. Number 3, I have a cubed divided by a cubed. A cubed divided by a cubed just completely reduce. Gives you 1. If you subtracted those exponents, 3 minus 3 is 0, and a to the 0 is 1 as well. Now, what we learned today or yesterday, the day before, adding and subtracting like terms. What's a cubed plus a cubed? How many of those do you have? Yep. How many? More. What's apple plus apple? What's a cubed plus a cubed? 2a cubed. If you need to, put little ones in front. We're adding 1 plus 1. Last but not least, what's a cubed minus a cubed? What's a cubed minus a cubed? 0. Trick question. Apple, if I have an apple and you take it away, now I have nothing, right? We got nada. All right. So, let me zoom out. Here we go. Get the whole thing on there so we can read it. So, ladies and gentlemen, we got chapter 8.2. We're looking to multiply a polynomial by a monomial. Okay, monomial means what? One term. Beautiful thing, guys, we've already done this before. It says we're applying the distributor property for goal number 1. You guys remember the distributor property? We did this way back in like unit 0. Okay, this is going to be so easy. So we're going to use the distributor property as we multiply a polynomial by a monomial. So this is going to go super fast. So here we go. As I zoom in here for you guys so you can see it. Oh, right. Okay, so you guys remember the distributor property? So we've got A, and we're going to put this on the rainbow. We're going to take A and distribute it to both terms, B and C. So A times B is AB, and A times C is AC. Okay? So for example, if I have 2 times 2x plus 3y, we're going to go ahead and distribute the 2 and multiply. What's 2 times 2x? 4x. 2 times 3y? We get 6y. 2 times 3, we get 6y. That's a 6. Okay. Also, you'll be dealing with powers now. So we're adding in the power idea. Okay, from chapter 7, we said if we're multiplying, we're adding our exponents. If the base is the same, exponents get added. So again, if I have x squared times x cubed, 2 plus 3 is now 5. That's x to the 5th. Okay, so that's our goal for today. We're going to start you off with some baby ones and then work our way up to some harder ones. Okay, so here we go. We're going to use that distributive property here. All right, we got 5 times 7n minus 2. Go ahead and take 5 times each one. 5 times 7n. Kai, what's 5 times 7n? 35n. And then 5 times negative 2, Audrey. 5 times negative 2. Negative. There we go. Boom. That's it. Now we're going to start grabbing in some x's, right? So I take a look at number 2. Now I got 2x times x plus 7. 2 times x. What is 2 times x? If you need to, you can write it like this so you can visualize it. What do you do with those exponents? What's x times x? That's 2x to what power? the second. Very good. Again, the idea is you're adding those exponents. Okay? And 2x times 7. 2x times 7 is just 14x. These are unlike terms. I cannot combine those guys. I leave them separate. One is x squared and one's an x. They're not the same. I got to leave them separate. So far, so good? So as I take a look at number 3, moving across. Now it's getting tougher. I have r squared s minus 3, and then that's times 6rs. If you need to, you could put the monomial 6rs in front and rewrite it so it's r squared s like this, and then minus 3. Just change the position. Okay? Do you have to do that? No. Okay, but some people like to see the monomial first, followed by your binomial. All right? So as I take a look, I'm just going to leave it the way it was. I'm going to take this guy times this guy. Right? So 6 times like a 1 in front is just 6. Now do your r's. What's r times r squared? Morgan, what's r times r squared? Think of this as a 1. That's a 2. What do we do with the 1 and the 2? Just add them. So that's r to the third power. And then what's s times s? Will, what's s times s?
S squared.
There you go. S squared. So far, so good. Now we're going to take this 6r, we're going to multiply it by negative 3. What's negative 3 times 6, Damien?
8 times 6.
Yeah. What's negative 3 times 6? Let's put the earbud away, bud. What's negative 3 times 6? Oh boy, so negative 18, and then rs. Perfect. Good job. All right, so we got 6r cubed s squared minus 18rs is our final answer. All right, any questions there? Let's skip over 4 real quick. Let's try this one. Why don't you guys try number 5? You're going to take 4t squared now and multiply it to this trinomial. To each one of these guys. So take a second, see what you get. Come together. Okay, I'm going to do a different color for each one. And then we'll come back and do the one that has a fraction on it. This is a good time to flag me down if they need help. Come on over. And then if you need your point 0, 1, 1, a, negative 1, 1, a, right? I think you got it. Flag me down if you need help. I'm going to make this a little bigger so we can see it. All right. So as I take a look, I got 4t squared times 3t squared. I'm doing this one in blue. So 4 times 3 we know is 12. And now what's t squared times t squared? That's t to the 4th. We add those exponents. All right, so the next one we're going to do in green. We have 4t squared times positive 2t. 4 times 2? 8. T squared times t is now t to the third power. Very good. We're just adding exponents. 2 plus 1 is 3. Last but not least, I've got 4t squared times negative 5. That is now negative 20t squared. Can I put all these guys together? No way. This is a t to the 4, t cubed, t squared. These are all different, or what we call unlike terms. So we can't do that. Okay, final answer. All right, so raise your hand if you got that right. Raise your hand. Raise your hand. Yes. All right, so most of you guys got it. If you didn't get it right, do you see your mistake? Okay, make sure we're adding those exponents and then the coefficients we're multiplying. All right, so here we go. Number 4. Now we start looking at a fraction. OMG, I'm scared. We're going to take 3/4 A and multiply by 8A. Okay, now if you're bad with fractions, that's okay. 5 out of 4 people are. You can always use your calculator. You can do 3 divided by 4 and then times 8. If you're going to do it by hand, and you can't do this in your head, we're going to take 3/4 times 8. Well, what happens when you take 3/4 times 8? What would you do here to simplify this? Any idea? Rylan, what do you do here? You can multiply 8 times 3 and then divide by 4, or if you want to deal with smaller numbers, you could divide by 4 first and then multiply by 3. What's 8 divided by 4? 2, and then 3 times 2 is 6. So 3/4 of 8 is 6. Okay? Again, that's the idea. If you multiply 3 times 8, it's 24, but divide by 4 is 6. So either way. Okay? What's A times A now? Yeah, A squared or A to the second. Perfect. Thanks. So far, so good. Then we do it again. We take 3/4 times 12. If you're bad with fractions, either do it off to the side or grab your calculator. 12 times 3/4 or 3/4 times 12. I usually divide first. I'll take the 12 and divide by 4. What's 12 divided by 4? 3. And then 3 times 3. 9er. So this is plus 9, and then there's no A. So A goes right there. So final answer is 6A squared plus 9A. There's nothing else for me to do. That's it. Okay, fractions look super scary, but again, if you go off to the side or use your calculator, 3/4 times 12, press enter, I should get the coefficient in front. All right, I do want to finish up number 6 here, going across. So here we go. We're going to take 4m. We're going to times this by every single one. Whee! Using different colors for each one so you can see them. So I got blue, green, and purple. So let's go ahead and do this blue one first. I've got 4m times 3n squared. First thing is coefficients. 4 and 3 multiply, right? We know that's 12. M times n squared. Are those different or same variables? One's m, one's n, so I have to keep them separate. Now, which one do you put first? Usually put the variable that's alphabetically first in alphabetical order first. So we'll put m first and then n squared. Those are different, so I got to leave them separate. So far, so good. All right, next we're going to do the green one. Woo! We're going to take 4 times 2, which we know is 8, and then m times n stays m times n. We usually put the variable first, that's in alphabetical order. Like if I had A, B, and C, I wouldn't do BAC or CAB. We would do ABC in alphabetical order. Okay. Last but not least, I'm going to take 4m times negative 4mn. What's 4 times negative 4, Dan? 4 times negative 4. Negative 16. What's m times m? M squared. And then it's just a little n at the end. Okay, good stuff. Now this is pretty good. I would probably rewrite this. I would probably put this guy on the other side because there's an m squared there. So usually we want the power of our leading variable to be in descending order. So I would probably write this as negative 16 m squared n plus 12m n squared plus 8m n. So usually we want that in descending order for the power of your leading alphabetical order term to go from 2, 1 to none. Okay? Questions? Again, we're not going to do every single one of these on the back, guys. We're going to do a couple more. Let's do a couple more here. Let's do number 7. Let's do number 7. I've got p times p minus 5, and then I have minus 4p times p plus 1. Okay, so let's go ahead and distribute. Woo! Taking that p times p minus 5. All right, so we take a look. P times p. Griff, what's p times p, bud?
P squared.
There you go. And p times negative 5, Griff?
Huh?
What's p times negative 5?
Oh, negative 5p.
Yes, sir. Good. Next, I'm going to take the negative 4p. Make sure you take the negative along for the ride times p plus 1. So go ahead and distribute. So I've got negative 4p times p. And Kelly, what's negative 4p times p? So negative 4, what's p times p? There you go. P second, p squared. And then negative 4p times 1 is just negative 4p. 1 times negative 4 is negative 4, and then a p. So far, so good? Quiz or test, if you leave it like this, it's wrong. I'm going to write simp on your paper, simplify. Is there some terms that I can add and subtract? Some like terms. I'm getting head shaking, yes. Okay, JP, what do you see? Yep, so these p's here, negative 5 and negative 4, this guy I'll circle and this guy. What's negative 5 minus 4? If you owe me $5 and borrow $4, now you owe me $9. Okay? But I also have this guy and this guy, the p squareds, right? What's p squared minus 4p squared? This brings you back to 8.1 stuff, chapter 8.1. Add those like terms. What's 1 minus 4? Negative 3 p squared. Again, we want to write in descending order so the power of p gets smaller and smaller, so put the negative 3p squared first, then the negative 9p. There we go. Yes, sir. Yeah, let's do a couple more and then we got to do it. You can go. So let's do number 9, you can go. So let's finish up with number 9, guys, and then if you want to see another one, we can. Last one says solve. When something says solve, at the end I should get x equals some number. This is the only time you should get x equals. Don't just do like number 7, then put an equal sign in there and try to solve it. Okay? All you want to do, like on those other ones, 1 through 6, is just simplify. There is no solving. But this one specifically says solve. I specifically see an equal sign right here. So I got to solve it. Okay? All right, so here we go. I'm going to take t times t minus 5. I'm going to go ahead and distribute. We did something just like that before. T times t is t squared. T times negative 5 is negative 5t. So far, so good. Then I have this plus 2t minus 1 over here. So plus 2t minus 1. I don't distribute the t to everything, only to what's in the parentheses. Okay, does that make sense? Any questions so far? All right. Equals. I can't combine anything over here until I go ahead and distribute. So I got 7t plus 3. And now I'm going to take this t and distribute. So I got t times 8. That's 8t. And t times t squared, or t times t is t squared. So far, so good. Any questions? Now this can be cleaned up a little bit, so let's kind of combine our like terms, okay, on each side. So over here I've got a t squared, and let's clean up this side. This is negative 5t plus 2t. What is negative 5 plus 2? How much is that? When it's on the same side, combine those like terms. That's negative 3t, very good. And then minus 1. On this side, I have a t squared, so I'll write that in green here. So I got that one taken care of. Then I have a 7t and an 8t. Well, what's 7 plus 8? Just combine your like terms, put them together. What's 7t plus 8t? 15t. And then I have a plus 3. Okay, so I've cleaned up the left side. I did that in blue. And then I cleaned up the right side. I did that in green. Okay, how are we doing? Did I lose anybody? Well, we want to solve for t, right? We want to get the t's on the same side and everything else on the other side, right? Well, how do we do that? Well, first off, let's move the t squareds over. Let's subtract that guy over. What happens? What's t squared minus t squared? What's apple minus apple? Nothing, right? That guy cancels. Look at that. So now I've got negative 3t minus 1 equals 15t plus 3. Well, that's an algebra problem we did lots and lots of times last semester. How do I solve for t here? What do I have to do? Suggestions. How do I solve for t? How do I get the t's together? Colton?
And give
Yeah. There you go. So go ahead and add 3t over. That cancels, right? So that's negative 1 equals 15t plus 3t is 18t. And then plus 3. Okay. Now we want to get the 3 on the other side, use subtraction. So I'm going to subtract that over. So if you owe me $1 and borrow $3, now you owe me $4. So I've got negative 4 equals 18t. And I got one more step. Tay, what do I got to do? Divide. Divide. I would reduce that by 2, right? 4, negative 4 eighteenths reduces by 2. What is that? Negative 2 ninths? Like that. Final answer. Woo! Okay. Now, is there a quiz question like that? Not on what is today? Tuesday? I'm not going to quiz you on that one. But that's kind of where we're going with this stuff. Okay, this is the stuff you're going to eventually start seeing. Okay. Ladies and gentlemen, that is it for today.